There's no problem. We can wait for a few more minutes for folks to join.
Yeah, we can start the event. It's fine.
Sorry, Jyoti, can you come again?
Can we start the event 10? It's fine.
Did you say 2:10?
Yes.
All right.
Abhishek, meanwhile, I think you can share the facing slide. Abhishek? Abhishek. Dhruti? Yeah, fine. Yeah, that is better.
Ma'am, can I start the session?
Yes, go ahead, start the session. Meanwhile, people will join
A
once the session starts.
Sure. A very good afternoon to one and all present here. I heartily welcome you all to Gurukul 2.0 initiative, the second session, a 2 days hands-on workshop on robotics. Active participation on both the days is appreciated. The event is hosted by Pylearn. Pylearn is a newly established education platform that focuses on providing quality content to students and assisting them on their academic journey. It was founded in 2020 by a team of enthusiastic, recently graduated engineers who have a vision of providing quality content and educational courses to enthusiastic learners of all experience and knowledge levels. Pylearn's motto is to help students learn without limits. Team Pylearn believes that students should be able to access a vast amount of knowledge without being restricted by course curriculum or rigid academic requirements. Pylearn provides a wide range of carefully curated courses targeted towards learners of different knowledge levels at minimal and negligible costs. Each course is thoroughly researched and carefully put together by Team Pylearn and provided by a subject matter expert. The courses on Pylearn span multiple different categories such as data science, programming, engineering design, blockchain, digital marketing, content marketing, embedded systems, and even courses on personal and financial development for young adults. Due to the pandemic, this workshop is being conducted online, so kindly bear with us in case of any technical issues. We will resolve them as soon as possible. I request all the participants to mute themselves and put their queries in the chat box. It will be addressed at the end of the session. Before we start the workshop, I would like to introduce the speaker for this event, Abhishek Shreemus. He currently works for L&T and is associated with IEEE for many years. He is also the former founder chair of IEEE Dayananda Sagar University, the core team member of IEEE TEMS India team, and a member of C team IEEE India Council from India IEEE Bangalore section. He has taught embedded systems related project based learning courses to more than 1,000 students from both schools and engineering colleges. We are glad to have you here with us as the speaker, Abhishek. Over to you for the rest of the workshop.
Okay, great. That was a very warm welcome and a great introduction from you, Dhriti. So I'm thankful for you to that. Okay, since we do not have too many people, it would be my pleasure to call everyone, call by name, starting from the Pushpa Mala, Madam, the host, and Dhruti, Advai, Chaitanya, Manoj Turmari, Karthik Nayak, Kushal, Lohit, Manoj, and Pushpa Mala, ma'am. Did you register from your two devices? We see two Pushpa here.
Yes.
Okay. And Shashank, Shreya, Saujanya, and Vaishak. Welcome to this session on robotics. Yeah, I'm Abhishek Shreemus, currently working for Larsen and Tobro, Whitefield, Bangalore. Okay, so let me just quickly get into the topic. Just you can show me a thumbs up symbol or a hand raise symbol when you can see my screen. All right. Okay, thanks Shashank. Thanks Manoj. Yeah. So thank you for the symbol. Okay, guys. So we do not have very large audience here. It's better in a way that we can keep the session as much as interactive possible. So I hardly see 10 to 15 people. I don't see the count here. So I shall try to deliver the best of my knowledge, and I shall expect you to be attentive for the complete 2 days of session, so that you can grab as much as possible. Okay. So I'll try my best, and then you should give your best to get what you want. All right, so on that basis I'll just move ahead. Okay guys, you can unmute yourself when there is an interactive session. So the first question would be, what is a robot? So any one of you can can answer this question. What is a robot?
machine that's programmed to act like a
Okay, that's actually correct in a way. Thanks, Shruti. So, okay, this particular definition is taken straight away from the Google. What is a robot? A robot is a machine, especially one programmable by a computer capable of carrying out a complex series of actions automatically. So, putting it into simple terms, a robot is a machine which can mimic human actions, right? If we are feeling something is tiresome or something is complex or something is hard, and if we feel like I should not be doing that, I need someone. Okay, during the industrial age, when during the industrial revolution, where people used to hire hire employees for doing complex works or repetitive works. But now it's not it's not the age of industrialization. It's the age of computerization, right? So that's the reason why we use a robot. Basically, a robot is a machine which can mimic human actions and then carry out tasks and works that a human wants to do. Okay, going further. So you just joined this session with the too many questions. So what are we doing, and then what are we learning today, and then why are we learning today? I mean why are we learning this? And then a series of questions like when, who, where, what. Okay, and you're all excited to learn this, I guess. Mhm. Okay, are we building this? So I hope 90 to 95% of the people knows this because he he's a famous personality. I'm not speaking about Taleva Rajnikant, but I'm speaking about Chitti, Chitti the robot, which is a famous character in Robo and Robo 2.0, right? Are we building this? No, we are not building this. And are we building this at least? So you guys know this? What is this? Can anyone tell this? Which particular bot is that in the picture? All right, no problem. So that particular bot is developed by Honda company, and its name is Asimo. No, it's Asimo. And are we building Chiti? No, we are not, because that's a way too complex, and then it's like a science fiction, right? And this is something advanced and something complex that needs enormous time and resources for building. So then what are we building? That shall be dealt in the end of the session today and in the upcoming session, that is tomorrow. Okay, so what is the difference between a human and a bot? Okay, I'll put the question the other way. What are the similarities between a human and a robot?
If we go by task, we have to follow a certain number of steps, and the robot will also have to follow the same steps to complete the task. So that's one similarity.
Yeah, that's nice, Shashank. So why don't we keep it simple, and just take your arms out and touch your face, just hover your fingers on your face and just tell me what all you can touch. You can touch your eyes. You have eyes, and then you have a nose, and then you have a mouth, and then you have two ears. Yeah, right. So what are those? So what do we call these? What do we call skin, eyes, nose, and ears together? We call them sense organs, right? folks, there, a small request, from my side. Let's keep it as interactive as possible. I know we know something, so let's unlearn and relearn. All right. So, speak out, guys. Uh, let's keep it as much as as interactive as possible. Okay. So if we come to the point of similarities between a human and a robot, we have sense organs, and then a bot has sensors, right?
Sir,
And yeah, uh, you can call me Abhi or Abhishek, and then no need to call me sir. And then you can shoot your questions to me right away if you have a doubt. No need to wait till the end of the session. Okay, we should clear it on the spot, and then we'll go forward. All right. So we have sense organs, and the bot has sensors. So we have we have our pair of hands, and then we have our legs, and then we have a mouth. So what are these? These are output. These are like output devices. So in the same way, the bot also has actuators. Actuators are the devices, which are used for output purpose. Just like sensors for input, we have actuators for output purpose. So that's the similarity between that. And then what is the difference between bot and a human?
What is done specific task, on what basis it is trained.
All right, you are almost on the right track. It is the processing power. A bot cannot think on its own, and when it comes to us humans, we have our own thinking and capability. We get the input, from a sense organs, and then we process it, and then we act accordingly. So in the same way, we need to provide some kind of a thinking part uh, to the bot that we are designing. And then, as you said, a bot is designed for a specific purpose, while we human can do many things, right? So how can we even introduce, or how can we put that thinking power into the bot? Any idea?
Artificial intelligence
Okay.
and machine learning.
programming, sir.
Okay, right. You are right. But you directly hop to the point number 10. You just missed point 1, 2, 3, 4, and 5, 6. So where do we implement our artificial intelligence and programs and algorithms? Where do we burn, or like, where do we dump them?
In a microcontroller sort.
Processor.
Right, that's the point. That's the point. We make use of microprocessors and microcontrollers. We'll see what is a difference between a microprocessor and a microcontroller. How to choose a microprocessor, for a particular task, or for a specific action, and all other things. We'll see in the upcoming slides. So till now we are clear about this. We need sensors for input. We need actuators for output, and then we need our embedded system. I mean, that is a microcontroller or microprocessor that inculcates the thinking part to the bot. All right. So what is a embedded system? So there might be a question in your mind. So why are we learning embedded systems? When we are dealing with robotics, okay, robotics, or or building a robot, it is very clear and evident that any robotics engineer must and should know what is a microcontroller and what is a microprocessor, and then what is the role of embedded system in building bots, because these are the fundamentals. Without knowing fundamentals, we cannot start any particular task. We can directly hop on to writing the first program, and then connecting the first hardware, and then running it. So it'll be just like a one day's task. But if you want to grow after that, if you want to take up a project on your own independently, that one day's knowledge shall not suffice. for the purpose. So we need to go from the fundamentals. We need to make our fundamentals strong. So that is why we are moving from basics of embedded systems. Okay, coming down to this, what is an embedded system? Embedded system is something that is that's a combination of both hardware and software. Okay, so we see many analog and digital circuits around us. So if you look at a watch, I mean, um, just a digital watch which you and me used to wear 10 years ago, that's just an electronic circuit. And then if you look at the Apple Watch, you look at noise, you look at few other few other wearable devices just like Fitbit and other. Those are all examples of embedded systems. So what is the difference between that is they are a combination of hardware and a software. So we see the hardware, that is the display. We see the display, and then we see a chipset within the watch, and then uh, uh, and then we see a battery module in that, and then there's a complete system on chip. So this is a combination of software and hardware. And coming down to the point that we in my watch actually, I just upload my profile, my picture onto my watch. My phone's wallpaper shall be made as a display picture for my watch. So how do I do that? I transfer from a cell phone to my watch. So what's happening over there, that's like on the air software programming. So when we are delivering this particular image from the cell phone to the wristwatch. So there's a software which is doing all the process, right? So that is the very big example of embedded system, okay, which you and me can easily connect to. Okay, in an embedded system, we have an input end, we have the other end called as output end, and then in between the input and output, we have a embedded computer. That's a mini computer with both software and hardware. So I guess we are clear about what is the basic definition of embedded system. Can I get a thumbs up if you are clear till this point? Yeah, thank you, folks. And then if you ever feel that my pace is is too fast or too slow, you can just just drop a message in the chat box directly to me. I can alter it. Okay. Next, so what are the examples of embedded systems which we see in our daily life, and then which are available off the shelf? Can we have an interaction about that? You can just go you can go on listing the embedded system boards that you worked on, or you have heard about, or you have seen. Yep. So let's start with you. Come on, guys.
Arduino Uno, Arduino Nano, and Raspberry Pi, and
Okay.
8051 controller.
Okay, next.
Mobile phones, and then
Yeah, guys, we know too many things. We just need to assemble them and then present them. That's all. Think on.
Uh,
Okay, I'll
all
start with this.
applications like microcontroller used in water vending machines.
Yeah, you're right. Right, Mithun. Oh, sorry, Mithan.
Uh,
Is
Road
it
MC,
Mithun or Mithan?
Mithan.
Sorry, Mithan. Okay, yeah, thanks for that. Okay, so when we speak about our cell phones and our washing machines, refrigerators, and few other electronic components, they're applications of embedded systems. Okay, when you I'm speaking about the boards, the microcontrollers. Okay, so I do not remember the name. Uh, uh, we started with Arduino Uno. Arduino Uno is the is the most commonly seen microcontroller that engineering students will be carrying in and around colleges. Okay, and from the same family of Arduino, we have Arduino. You can see here to the left corner, we have Pro Mini, we have Micro, we have Nano, and you know a few others are not listed here actually. So we have Arduino Mega, and then we have Arduino LilyPad, and a few others in the Arduino family. And then you can see here in the in the center top, yeah, we have zero. Which board is it? Any idea?
Raspberry Pi.
Yeah, right. You're right. That's a Pi Zero. Actually, Pi starts with Pi Zero, and then we have a few other series, and the most recent launches. Any idea, guys? So let's keep it in the interactive, as I said in the beginning. Let me learn from you, and then let me deliver you whatever I know. So, which is the most recent launch launch by the Raspberry community? That is the Element 14 community. Any idea?
Pico, sir.
No, it is Raspberry Pi 4. Pi 4 is the is the recent launch by Element 14 community. So whatever you see is the Raspberry Pi. Raspberry Pi is one particular board from the Element 14 community. So the developers of Raspberry Pi are Element 14. Okay. Okay. We have Raspberry Pi, Pi 3, Pi 3B, Pi 3B plus, and then we have Pi 4. And then if you look at the difference between Pi 3 and Pi 3B, Pi 3B plus 4, it's all a minor difference in terms of features. So in some boards we have in Pi 3B we have Bluetooth. In Pi 3B plus we have Bluetooth 4.2, and then Bluetooth 5. And then when you come to Pi 4, it has got very advanced processing system, and then it has got 4 GB of RAM. When it comes to Pi 3B and Pi 3B plus, there was only 1 GB of RAM. And yeah, I'm right, it's 1 GB. I was confused between 1 and 2. It's 1 GB. And then when it comes to Pi 4, yeah, as you can look here, choice of RAM in the to the top right corner. We have a choice between 1 GB, 2 GB, and 4 GB. So this is the difference between Pi 3, Pi 3B plus, and Pi 4. All right. Okay. So this is the Raspberry. Yeah, this is the Raspberry Pi. Yeah, this is Pi, and the to the left is Arduino Uno, and to your right is the Beagle Black. Okay, let me tell you a few other names of famous microcontrollers which shall be used in industries. Have you heard of Orange Pi? Orange Pi, then we have Banana Pi, then a few boards like we have Latte Panda, and then we have Onion, then we have Beagle, then we have and then we have Jetson Nano by Nvidia, and then somebody was telling about artificial intelligence and machine learning. If Raspberry Pi cannot suffice the purpose of machine learning and artificial intelligence, so that is the reason Nvidia launched the Jetson Nano board. That is very vastly used for these robust algorithms like CNN, NLP, and ML and AI. Okay, from the left is the Arduino Uno, and we have Raspberry Pi, then we have BeagleBone. Okay, where coming down to the point of manufacturers. Okay, you can look at the percentage of microcontrollers being used in industries. So at the top we have Texas Instruments, and then Freescale. We have Freescale, and then Atmel. So whatever you see in the Arduino Uno, the microcontroller that we are using is Atmega 328P. So Atmega, as it is 80 is comma it is controlled by the company Atmel. So if you look at this, many companies have been acquired by few other giants in the industry. So this is the market share. Okay, so what is the architecture of an embedded system? As we discussed in the previous slide, embedded system is a combination of hardware and software, and then it also needs operating system. When it comes down to Arduino Uno, it doesn't need a big operating system, in fact. But when you look at Raspberry Pi, we definitely need need an operating system. So have any of you worked on Raspberry Pi and uploaded the operating system on top of it? If yes, which operating system have you used?
So free RTOs.
Great. Then, okay, let me break the ice. So we have something called as Raspbian from the Raspberry Pi community itself. So that is actually based on Linux environment. So moreover, it looks like working with Ubuntu. Okay, that's a launch by Raspberry community. We call it as Raspbian, and then we can also use Linux. And if you're working on on embedded applications related to network management, and then related to sniffing or hacking, okay, I mean ethical hacking. So we shall be using Kali Linux. So basically, we shall be using different variants of Linux, and as Shashank said, we'll be using free RTOS. Okay, RTOS is nothing but a real-time operating system. Okay, so this is the architecture of an embedded system. Okay, and then we have something called as system on chip. So we have a microcontroller. Yeah, so we have a microcontroller chip with us. And then if we need if we want to enable that microcontroller to perform the actions based on the inputs we give, it needs a few other peripherals. Something like so if we have an analog input, and then if the microcontroller accepts only the digital input, we need to convert that. So for that purpose we need an ADC, I mean analog to digital converter. And in the same way, we need a DAC, to convert digital to analog. And then if we are using communication protocols, that is UART. And if we and we also need a RAM. Okay, and then we need a few set of amplifiers to amplify the signal, which is very weak. And just like that, we have a few other you know few other components around the microcontroller. If we include all those I mean all those peripherals on a single board, that particular board would be called a system on chip. So as you can see here in the picture depicts very clearly, we have ADC, we have DAC, this is LCD drive, if you are connecting any LCD display for that. And you have a amplifier, you have filter, you have UART, and here you have SPI, USB, for communication purpose. And then we have RAM, and then you have non-volatile SRAM, and then you have counters, and a few others. Yeah, and then here we have ARM, and then we have 8051, we have M8. Uh, Guys, can we just go back, little, back in time, and then look at what is the evolution of microcontrollers. So, which was the first microcontroller designed? Any idea? Intel 404. I mean, 4004. Have you heard of it? 400
Yes, sir.
with only 4 bytes of RAM, and and then coming, next we have the 8008. Then we have 8051, 8085, 84, yeah, 8081. Then we have Intel's dual core Pentium, and a few others. Yeah, so that's the evolution of microcontrollers or microprocessors. Okay, so let's also discuss about what is the difference between a microprocessor and a microcontroller. Any rough idea about that?
Microcontroller can deal with specific number of tasks while microprocessor can deal with many number of tasks at the same time.
All right. Any more?
Sir, a microcontroller would consist of a microprocessor plus memory and also some additional, say, input-output mechanisms and timer and counters, that's it, on a single
Yeah,
chip.
perfect. Perfect. Yeah, you got it right. A microprocessor, what it does is, if you give some input into the into your computer system, okay, say you have a Intel Core i5 with 10th or 11th gen or i7. So what it does, it is a microprocessor. So what it does is, we just provide the input to the input through our keyboard. It just processes that, and then it will show the output on your display. So it'll only process something which is being fed to that, but in turn it cannot control, it cannot command something to actuate, or it cannot work with other peripherals, work with other hardware actuators. So that is the basic difference between microprocessor and a microcontroller. Microprocessor, if you give some input, it'll just process it, based on the command lines it has got. I mean, it's being trained, and then it'll provide the output. But a microcontroller is something different. In fact, we can convert a processor into microcontroller. Okay, when you look at a Raspberry Pi, we can just process the input, process the data, input data, and then in turn we can also use it for actuation purpose. So we can use it in both the ways, right? So it's a best example of system on chip, Raspberry Pi, because it has got enormous amount of RAM and memory allocations. Okay. So when it comes to microcontroller, it can make use of the peripheral devices. It can control input and output devices. Okay. So this is the very basic level of definition, which we can discuss about microcontroller unit. So coming down to microcontrollers, we'll be calling them as MCU in short. MCU stands for microcontroller unit. All right, going ahead. Okay, so what are the different stages of mm, developing a prototype? Say if you have an idea, idea in your mind. You saw a problem, you got a problem, and then you thought of a solution. Uh, I mean, you thought of a solution to deal with the problem by making use of embedded system or robotics. Okay, so how do you go forward? So what are the different stages of converting your idea into prototype, or a prototype into a product? That's left to the user. So when it comes to this, freeze the requirements, and develop the sketch, burn the sketch, compile, and in the last we have it is the test cases. So let me ask you a question. How do you choose a set of sensors, or how do you choose a microcontroller, or how do you choose a set of sensors and actuators? Okay, let's brainstorm on this.
So first I think you'll have to look at the capabilities of the different microcontrollers and be aware of the uh, things in the market and their capabilities. Then look for our specific task which we want to achieve.
Right, you're right. So any more definitions for the same? Oh yeah. So if you want to sense temperature, so which kind of sensor are we going to use? We definitely use a temperature sensor, right? Yes or no?
DHT.
Yes, sir.
Yes, yes. So first we need to look at the the parameters that we are sensing. If we are sensing the pressure, we need to find the pressure sensor, BMP 180. If if we are sensing temperature, we need to find a LM35. If you are sensing some other, you need to find the appropriate sensor. So you need to make sure which parameter you are sensing, and then you should get the appropriate sensor. That's the first one. And what is the output from that particular sensor? When I say output, is it a analog output that we are getting, or is it a digital output that that the sensor is providing to the microcontroller? If it is providing a digital or analog, we need to mark that. And then at the same time, we should look at the microcontroller. So does my microcontroller accept analog input, or does it accept only digital input? Because most of the cases, we shall be having a majority of digital inputs, digital inouts than analog. So we should look at the number of input pins and the output pins, and then in analog and digital input output pins in the microcontroller. So we should look at that. And then what is the bit size, like what is the width of the bit width of the data that the microcontroller accepts, and then what is that the sensor is giving as the output. So we need to look at that. And then if needed, we need to include an ADC or a DAC. So that is about phrasing the requirements. This is about the input, and then in the same way we should also get the appropriate output devices. So that's about phrasing the requirements. And then the second part is develop the sketch. So here when we say sketch, sketch refers to the program or the algorithm, or the program which we are developing, through various IDEs. IDE stands for Integrated Development Environment. So you might have, mm, gone through the Eclipse IDE, Arduino IDE, and Anaconda, or or Jupyter, like that. In that series, IDE stands for Integrated Development Environment, where we are going to develop sketch, and compile it. Okay, next is the burn the sketch. I mean, what do you mean by burn? Is we are going to dump the program which is being developed in the computer onto our microcontroller unit. That is the MCU. And the fourth step is compile and run. Of course, it shall be included in the develop the sketch icon itself. That's need not to be mentioned again. And the last one is the test cases. You're going to test the prototype, or the program that is being developed, and the hardware that is being connected for different test cases. All right. So this is about different stages. Okay. In this workshop, we shall be using Arduino IDE for development of sketch. So as I said, we shall be using Arduino IDE and Tinkercad. So why are we using Tinkercad is, it's very clear to you and me that we cannot run a hands-on workshop physically, because the COVID outbreak in and around us in Bangalore. So that's the reason we are going for online simulation of the hardware. All right. So next, the world around us is digital and analog. Okay, so why I'm specifying this digital and analog is we shall be using these terms and these conditions while we are developing the sketch. Maybe end of the day today, or tomorrow's session. Okay, so the digital world is represented using zeros and ones. So I hope we are we all are engineers, or are budding engineers. So we know what is the difference between analog and digital. So can somebody put out the definition in a simplistic way? Okay, guys. So when it comes to analog, we keep track of all the values, at all the points of, all the time points. But in digital, we just only look at the levels. It is a 0 level or 1 level. Okay, so that is the basic difference between analog and digital. Okay, so you shall also need to know the fundamentals of C programming, because when you are working with Arduino IDE, we shall be using embedded C. we shall be using embedded C programming language. So for that thing, you should know what are the different data types available in C programming language. So we have int, char for character, float for decimal, and double again for the double precision decimal. And then we have boolean. Sometimes we shall be using boolean. We for the programming within the like within the case of the sketch, which it cannot go out of the sketch. Okay, in those conditions we shall be using a boolean. Okay, so what are we going to build today and tomorrow? So these are the things that we are going to build. We are going to develop the code, develop the sketch, and then we are going to simulate it virtually. So we are going to build a obstacle detection bot, line follower bot, firefighter bot, motion detection bot, and we shall also be working on a wireless control system. We shall be using Bluetooth for that purpose. Okay, hardware components. So coming down to this obstacle detection robot. So you might have seen it, or you might have even worked on it. But let me have this interactive. Okay. So what all the hardware requirements should be needed for this? Any rough idea?
Ultrasonic sensor or IR sensor.
Oh, you are right, Mithun. We just need if we are sensing the obstacle ahead of the bot, we need a sensor which can scan the range beyond the, in front of the bot. So for that reason we can use an infrared sensor or an ultrasonic sensor. Okay, the working principle is same, but the mode of operation is different when it comes to IR and ultrasonic sensor. So in this case we shall be using a microcontroller, and then we shall be using a pair of IR sensors. Then and then we can also use LEDs if needed, and we need L298 motor driver. I'll tell you why we need a motor driver. And then we need a pair of DC motors, at least a pair, and then we need a SMPS or a power supply, and then we shall be using a Hc05 module. Okay, so let's get our hands dirty for some time. Okay, IR sensor. Okay, guys, it's very necessary to know the working operation. I mean, to know the phenomenon, what's happening within the sensor before you connect, or you actually start working on the hardware. Because when you burn a hardware component, it would be very hard for you to procure it again, in the given time, right? So this is the like these are the infrared sensors. There's a difference between the first image and the second image. Can you guess that? It's pretty simple though.
The number of pins.
Yeah, Mithun, you're right. So it's about the number of input or output pins. In the first image, we have 3 pins. Now, if you can look at it very closely, you can see something written as out. It's output, and then to the other end we have VCC. So what would be the missing terminal there? Any guess? So for any electronic circuit, we need a input and a ground, right? We need a positive and a negative terminal. So we have VCC. So we see here VCC means the input voltage. That is the input operating voltage. That is from 3.3 volts to 5 volts. It might vary. And then the other end we have the output terminal. So what would be the terminal which is in the middle of VCC and output? It would be ground, right? It should be ground. And in the second picture, we have 4 terminals. We have A naught, B naught, or AO or DO, G, and VCC. So AO is nothing but the analog output. DO stands for digital output. G is for ground, and VCC is for the input voltage. So if we need to power up, this particular IR sensor, and if we need to get the output, we need to connect a ground to the ground terminal, and a 5 volts or a 3.3 would be enough for this particular IR sensor. 3.3 to 5 volts of power supplied to this VCC terminal. And then if we need the digital output from this, we are going to make use of D out. And then if we need analog, if we are going to make use of A out. So nowadays, in most of the sensors that that are available off the shelf, we are we are finding it tough to find the sensor with A out, with the analog output, because most of the sensors are manufactured with only digital output. Okay, so here to the left of the slide, you can see the working principle of an infrared sensor. So we have a transmitter, we have a transmitter, and then we have a receiver. So the transmitter transmits, and then it bounces back to the receiver, and then it receives. So based on the potential obtained, it shall be converted into a corresponding electrical signal. So that is this is the working of an infrared sensor. Okay, you might have seen these infrared sensors, within the television remotes, at our houses. Okay, so it we cannot actually look the infrared ray, because its wavelength is beyond the wavelength of the visible light. So we cannot look at that with our naked eyes. Next, here for the motion detection bot, we shall be using a PIR sensor. PIR sensor, PIR is nothing but passive infrared sensor. So this is the working of the infrared sensor. So it has got two slits, and then it has got a Fresnel or a Fresnel lens. So whatever you can call it, as per your convenience. So it has got two slits. In the first slit, it will be radiating infrared radiation. So when a human or a human body enters that, based on that, there shall be a fluctuation in the value. Okay, so it will generate a potential, a positive potential. As you can see here, when the man enters the red zone, there's a positive spike, and then when he leaves the red, and then when he enters into the green zone, there's a negative spike. So based on this potential difference, based on this negative and positive potential, the the sensor would be generating a corresponding electrical signal. So that that is what we call as a output value of the PIR sensor. So this is the PIR, and as I told, the out of these three pins, one would be for ground, one would be for VCC, and the other would be um, for output from the sensor. So here, in this picture, it is not actually shown, but you'll be having two particular potentiometers. So for the first one for the selectivity, and the second one is for the voltage. Okay, so if you increase the voltage, it will be correspondingly or linearly increasing the range of the sensor. Okay, and we discussed about motor driver. So this is a motor driver module. Uh, okay, so this is a L29 3D motor driver module, and this is a L298 motor driver module. So why do we need a motor driver? Is when you're working with a bot, say you are working with a bot which has got two wheels, okay, and two wheels are connected to the DC motors in turn. Yeah. So you have your input infrared sensors. You sense something, and then you ask your microcontroller to stop the bot. Okay, or when there's no obstacle, you ask the command should ask the motors to start running. So when the motors are are running, it needs minimum of 5 to 6 volts of voltage, and then at least 0.5 to 1 amps of current, like based on the motor standard motor requirements. So when you look at the input to the to the microcontroller unit, you shall be providing only 5 volts and then 0.35 amps of current. So when you are supplying 0.35 amps of current into the microcontroller unit, and then you are in turn connecting the microcontroller unit to a pair of DC motors which need around 0.5 amps of current. So how can you uh, make sure that the the motors run properly and the board doesn't, I mean, the actual microcontroller board, doesn't burn out, right? So for that reason, we needed a driver module. So what's the purpose of this driver module is it just takes the command from the microcontroller, and then it takes the power supply from the external power supply, and it drives the a pair of wheels, or whatever is a set of actuators that you have been included, that you included into your project, or your microcontroller, or into your embedded system. Okay, so that is the need of the driver module. So what is the difference between L293D and what is the difference between L298D is number of input and output pins. So based on their operation, by using okay, this is L293D IC, and then this is the L293D module, motor driver module. And here what you see in red color is the L298 module. So you can connect four. You see here you have out one, out two, out three, and out four, right? You can connect four motors, or two motors in the forward direction, and also in the reverse direction. So we shall and look at that in the simulation part. Okay, are we clear? Are we clear till this point?
Yes, sir.
All right, going ahead. So this is something additional you might need, or you might not, but I'll discuss on this. Okay, you have LM7812 and 7805. Uh, okay, any electronic student can know the difference between 7812 and 7805. So can anybody tell the difference between these two? And then like what is the purpose of using these LM7812 and 7805? Okay, you can see in the picture it says voltage regulator IC. So what is a transformer? A transformer converts AC to DC, and then we have step down transformers, and then step up transformers, right? In the same way, we shall be using, and then does anyone wants to speak? Okay. In the same way, we are using 7812 for controlling the voltage to 12 volts, and 7805 for getting it to 5 volts. So these are voltage regulator ICs. Okay, this is Hc05 a Bluetooth module. So this is the Bluetooth module that we shall be making use of uh, to communicate with our Android devices, from our microcontroller unit. So this is Hc05. So as you can see here, it has got 1, 2, 3, 5 pins. So starting from the left, it is enable, and a voltage input. Then we have a ground, and then this is TX and RX. So TX and RX stands for the transmission and the reception end of this particular module, and then we have state. We do not use the state in most of the cases. Okay, so with this we come to the end of the theory part of this, and then we shall go ahead with Arduino IDE. All right.
Could you go over the Bluetooth model once more?
Uh, all right, Shashank. So this is Hc05 module, which we shall be using for communication through Bluetooth protocol. Okay. So this so right now in the market we have Bluetooth modules with Bluetooth 4.2 and with 4.2. So I'm not sure if if this is 4.2 or if, just Bluetooth 4. Okay, so it has got 5 pins. The first one is enable and VCC, ground, TX and RX and state. So we shall be connecting this TX pin from this Bluetooth module to the RX pin of the Arduino, or any particular microcontroller for that matter, and the RX. Okay, and the RX to the TX pin of that particular board. So why is this? Because whatever is is the transmission from this particular board, I mean this particular module should be the receiving part for that particular microcontroller, right? So if I transmit, you should be the receiver, and if you transmit, I should be the receiver. In the same way, these Rx and Tx are connected to the microcontroller boards. So you should keep it in mind, while connecting this Bluetooth. And then we have Hc05. After Hc05 we have Hc06. Hc06 might stand for ultrasonic sensors. And then apart from this, we might also use NRF to, yeah, NRF, that is near radio frequency chipsets. And apart from that, we can also use ESP8266 for communication over Wi-Fi. Okay, and then like that we have a like we have different set of of modules for different protocols. Okay, this one is for Bluetooth. Okay, guys, are we clear with this till here?
Yes, sir. Thank you.
Yeah. Okay, so if you all have a a proper internet connection with a good with a good PC, you can just open the Tinkercad as website, and then start the simulation of the hardware. First, we'll look at the hardware part, and then we'll look into the software coding. Yeah. Okay, folks. So when you are ready with the internet connection and the web page, you can just you know show a thumbs up so we can start working on it. All right. So I'll show you how to open it. I'll share my screen. Okay, okay, do you folks see my screen? A quick yes from you. Okay, so this is Tinkercad. So you just need to open this particular website and register yourself, and then we are going to click on create a new design. Okay, let me go back. Okay, when you're at this point, just look, you got to look out for circuits, not for 3D designs. Okay, just click on circuits and then create new circuit. Just take some time for setting up your PC, and you can send me a message that you are ready so that we can start. We all can go together. Okay, Shashank, what is the status, Shashank?
Done, sir. I've set it up.
Chaitanya and Apeksha, Dhruti, Kushal,
So I've set it up.
yeah, Mithun, Saujanya.
Yes, sir. Sets.
Okay, shall we march ahead? What is the response? Okay, yeah. Okay, I hope my screen is visible to all of you there. Okay, guys, at least for the hardware connection part, we shall interact with each other because there are chances of both you and me, making like making the connections wrongly, and there are chances of burning up the board totally at the end. So let's keep it interactive. So we shall discuss before connecting any point to any terminal, right? So hope we are all on the same stand. All right. So what is the first thing that we need to bring for a project? I mean, for this particular embedded project. Here you see, a set of hardware components. Okay. So what is the first thing that we need to bring? So when I speak about first thing, we need to bring the brain of the of the system. Okay. With this clue, can you please tell me like what is that we need to bring in here?
The RD, sir.
Yeah, you're right. So as we discussed in the first half of the session, it is the brain that needs the thinking power, right? I mean, that gives us the ability to think. So we have our brain here. So we need something to see or something to sense. So we need to sense the obstacle, ahead of us, right? Okay. So we just get we'll get the IR sensor. If the IR sensor is not available, we'll just go with the PIR sensor. Okay. Okay, here we got the PIR sensor. Okay, so this is the power and this is the ground, and okay, just a minute. Yeah, so we got the PIR sensor. So how do we know which is the terminal, which is the output terminal, or which is the input terminal, or which is the ground, right? So before going to that, let's discuss about this particular board which we are having at our hand. Okay, so we see pin number 0 to pin number 13, right? And here we see A0 to A5, and here we see power pins. Okay, this is the power sector of this particular board. This is the analog input, and when it comes to the upper half of the board, these are the digital input outputs. So you can one question is it says only input, analog input or digital input. Can we use this as an output also? Yes, we can use any of the pins or in the microcontroller as input or output pins, and then we need to configure the operation, I mean the mode of operation, either as input mode or output mode in the sketch or the in the program that we are going to develop. And when it comes to the last slide in the theory part, I told you that we need to connect this TX and RX. Okay, this is like these are the TX and RX pins for this particular board. So this board has got SPI connection also. Okay, so it has got SPI, and then you can take signals from these particular pins. Okay, now you see here, there's something called as this AC current. We show AC, right? In the as a wave, half wave. So here it is, at number 11, 10, 9, and then 6, 5, 3. So these are nothing but PWM pins. So PWM stands for pulse width modulation. So we are going to make use of this when we are going to deal with complex circuits. Okay, so these are pulse width modulation pins, and it used to be remember that pin number 3, 5, 6, 9, 10, and 11 support for pin number, they support pulse width modulation. And when it comes to this pin number, pin numbers after a reference is SDA and SCL. So SCL stands for serial clock, so and SDA stands for serial data. So these two pins are used for communication, and then also for some advanced circuits. So when you look at your keyboard of your computer, it makes use of SCL. And then when you are configuring this particular board as a master to some other board, or when you're configuring this particular board to a slave of as a slave to some other board, you are going to make use of SCL and SDA. Okay, in that master slave operation, we are going to make use of SCL and SDA, and also with certain actuator or certain input devices which make use of this particular configurations. All right, so here we have a reset 3.3 volts, 5 volts, ground, and V in. So this particular V in, it can act as the input power supply to the board. Okay, and when there is an external power supply through either through the power supply cord or through the USB cord, this can act as a power output to the sensors or the actuators. Okay, so this particular board has got three modes of getting the input. The first one is through USB. So when you're connecting this particular board to your computer, you can transfer the code, or you can burn the code from your computer to the board through this cable. This cable is generally called as printer cable, because this is the cable used for connecting your computer to the printer at your home or office, wherever it is. And this is the power supply. This power supply shall be taking 5 volts input. All right. So if you're not powering this particular board through this or this, you can use this particular V input for power supply. And then if you're powering from any of these two, in any one of these two, you can use this. Okay. And when you are working with the serial communication, or with the wireless or wired communication protocols, when you're transferring and receiving, how do you know that data is being transferred and received? You see two particular LEDs, TX and RX. So the RX and TX will be blinking, and blinking continuously when there's a communication happening through the TX and RX pins. All right. So I guess I covered most of the things related to the board. Now it's time for us to connect. All right. So you see here, this is a signal, this is power, and this is ground. So we see ground here, right? So we need to connect. Okay. So we want to connect this particular ground to the ground of this. Okay. Are you all with me? Are you looking at your particular boards on your PC, and then making the same connections? Are we on the same stand?
So,
Yeah. Hope that we are on the same platform with same knowledge regarding to this. Okay, next we have the power. So which pin should we connect this power to?
High volts.
All right, because its operating voltage is from 3.3 to 5 volts. So before using any hardware component, we should look at the data sheet. So where shall we get the data sheet? We shall get the data sheet from the internet. So we shall look at the number, the configuration or the serial number of that particular device, and then we'll search for the for that in the internet, and then we'll look into the data sheet before connecting any particular hardware that is needed, at least for us engineers. Okay, so I'll just take it all the way. Okay, all the way till here, and take a curve. Okay, all right. Let me change this color. Okay, this is power and this is ground. So our particular circuit is activated. So for any particular electronic circuit, we need power supply and ground. So ground is provided, and then voltage supply is connected. So we need to take the signal from the sensor to the microcontroller. So which pin should we connect this to? Come on, guys, come on.
Sir, one of the analog in.
Or okay, let me clarify the question. If you see that there is a D0 mentioned, I mean DO mentioned at that particular pin, or AO mentioned at that particular pin, where shall you connect? Shall you connect? I mean, will you connect that to the analog section or to the digital section? If there is an analog output from the sensor, we should connect that to the analog pin. Okay, analog is here, in A0 to F5. If it is a digital output, we can connect this to any of the pins here except pin number 13. Okay, do not connect pin number connect anything to pin number 13, because pin number 13 is in turn is connected to the LED over here. So when you connect something to pin number 13, it will be connected to LED in turn. So it will be a mess there. You shall not know what's happening at certain times. So it's always a suggestion not to connect any terminal to pin number 13. Okay, now I assume that it is a digital output. So I'll take this and I'll leave the pin number 0 and 1, because those are for communication protocols. And I'll connect this to pin number 2. Okay, so our first sensor is being connected, and then circuit is closed. Data is being obtained. So how do you see the data? That's in the next part, that we shall see later. Okay, we got the input, then we need to connect. Okay, if there's a PIR, okay, suppose this is an infrared sensor. Okay, if this is an infrared module, we are going to connect two particular motors, right? I need to select motors. Guys, are we doing it parallelly, or you're just looking at what I'm doing?
They're doing it, sir.
Okay, very nice. All right, I got two motors. Okay, so if there's any motion detected, you got to run this particular motors. Okay, so suppose this particular board and wheels are connected to a robot, a rectangular bot with two wheels, at two ends, and then we have got a proximity infrared sensor, at its front end. Okay, at the front it shall be detecting the motion. If there's any motion detected, the bot shall move forward. Okay, all right. So that is the case. Else, if there is no motion, we shall stop the bot there. Okay. So let's make the connection for these motors. So here we see it is a positive. Okay, let me take this here. All right, I got two motors. So let me connect the positive of this to one of the terminals. Okay, so in case if I want only one particular motor to move, I should send my command from that particular terminal to this motor, right? So I shall be connecting this to one of the pins, that is pin number 4. This is D4. Why is this D4? Because it is digital. Okay, so in the same way I shall be connecting this. Now, if I want to move only the right motor, I shall send the command only to the right motor, not to the left one. So that is the reason I shall be connecting this to another terminal. Okay, another data terminal. All right. Now the positive is connected. So if there is any detection, the board shall send a command to this via this particular wire. Okay, and then what's remaining is ground. So so we have only two particular grounds over here, and then we have three components here. This is a simplistic circuit. Okay, so how do we connect grounds? So suppose if we have 5 to 10 actuators or sensors, and then all of them need ground. So we have only two here in the power sector, and then one in the digital sector. So how do we make use of three pins, and then we shall connect them to uh, many electronic circuits. So we shall, for that case, we shall make use of the common ground. So there's no need to say that every ground should be individually connected to the board. We can make
has lost connection. He will be back in.
Hello, do you guys hear me?
So,
Because I lost the connection in between, I do not know till which point you could see my screen.
we connected the motors and we were going to connect it to the common ground.
Okay. Thank you, Shank. Okay, now you can see my screen, right? Yeah. So I just connected this to the common ground over here. Okay. I just brought this wire here, connected it, and then I extended it till this point, and then I connected to this ground. Clear? Okay, guys. So this is the hardware part of it. So let's look at the coding part. How do we connect this to the connect this particular hardware to the software part? Okay. Okay, guys. Meanwhile, you can just log into the Arduino.cc website and get your cloud IDE ready, right? Yes, I got it set right. Okay, you can just go to Arduino.cc website, and then you can select cloud, and from the cloud you can select your plan as try for free, and from there you can select the Arduino web editor. Okay, this is the web editor. Okay, uh, just give me a thumbs up when you are ready with this. Yeah, shall we continue, guys? Shashank, shall we continue? And
Yes, sir.
Saujanya? Yeah.
Sir, I have a doubt.
Yeah, yeah. Go ahead.
No, it can only power only like 5 volts. Say we need to use applications which require greater voltage, then what do we do, sir?
Okay, that's a question. I mean, that's a question of very great importance here when you are dealing with hardware. We are using our Arduino only for the for the processing and then commanding part, right? So in that case, say for example, you have motors, in the previous sketch, in the previous hardware connection, we looked at that particular design. It had two motors, wherein those two motors together need more than 1 amp of current. So Arduino doesn't take such that much of input, and even if it takes that much of input through its pinouts, I mean through its digital connections, the digital terminals, it cannot provide that particular amount of current. So that is the reason we are going to make use of drivers, external motor drivers. Okay, so say for example, you have a Arduino, and then you have a stepper motor. So what's the power requirements of stepper motor, and then it is very greater than what Arduino can take, or what Arduino can supply. So that is the reason we have particular motor driver. So to that motor driver, we just provide external supply of 12 volts. All right, and we just provide the command from Arduino to that particular motor driver. In the sense, one terminal, I mean, say if I sense something, if there's an obstacle in front of the air sensor, the Arduino should trigger a command to the motor to start running. Okay, so instead of giving that command to the motor, we shall be giving that command to the motor driver. So what that motor driver does is, it will enable the connection between the power supply and the motor. Okay, so this motor driver will act as a mediator between the command center. Here the command center is the Arduino or any microcontroller, and the at the other end we have the actuator, which needs more power, in terms of current and also voltage. So it will take the command from that, when to turn it on, and then when to turn it off. Okay, in that way we can make use of external power supply and then drivers. So this motor driver, we call it motor drivers because we are generally using it for motors. It's not only for motors. You can use it for any application for that purpose, for that matter and purpose. Okay.
Yes, sir. Thank
Yeah. Okay, Shashank. Yeah. So here you can download the software from the Arduino.cc also. You can download the Arduino IDE, and then you can have it handy in your computer for the tomorrow's session. Okay. Here, uh, first we shall list. We have infrared sensor. Okay. So we have IR sensor. Okay. And then what else do we have? We have a pair of motors, right? Motor 1, and then we have motor 2, So for now, we have this, these three components. One is this input and two is outputs. So our Arduino doesn't know which particular element is connected to which terminal of it, and then it doesn't even know if it is an input or output. So we need to configure that to the either to the input mode or to the output mode. So the output from these particular, from this particular sensor or input device will be in the integer format. It'll start from 0, and it'll reach a maximum of 256, based on the width of the bit size on the width of that particular ADC. Okay, so it'll be int. All right, so this is int IR sensor 1. So this is why I told you that we shall be making use of data types in the theory part. So okay, so whatever we spoke about in the theory, we shall be making use of it here in the practical session. And then even the motor, okay, motor should be should receive a command of either turn on or turn off. Okay, that command will be digital command. So when it comes to digital, it will be either 0 or 1. So 0 and 1 fall into the integer category, right? So that's the reason we are going to make use of int. Okay, just give me a second. I'll just switch my network from phone hotspot to the Wi-Fi router. Okay, the switching is done. The connection is back, right? You can hear me.
Yeah.
Yes or no? Yeah, thanks. So here our board doesn't know if it is in the input mode or output mode, right? Now out of these three, which one is the input and which one is the output? It doesn't know. So we need to specify the mode of operation. So that's the we need to specify which pin is acting in which mode. That is the reason we make use of pin mode. Okay, it's not there. Okay, you need to be very careful about the keywords which are being used here. So when you look at here, this is a two word keyword. I mean, this keyword is made up of two words. That the first one is in the lowercase, and the first letter of the second word shall always be in the uppercase. So when you type in the other way around, it shall not be highlighted. Okay, so this is this pin mode is used to specify what is the mode of operation. Okay, and now I need to specify to which pin is this IR sensor connected. So as we saw in the circuit diagram, it was connected to pin number 2 or D2, right? So in short, it is pin number 2. Okay, so I should specify pin number 2 is an input device. So whatever comes from this pin number 2, you should accept it as an input. So this is the command which we are giving here. Next, we have pin mode. Okay, here sensor. Okay, let me look at the circuit. Pin number motor is connected to pin number 4 and 5. Okay, just a minute. Yes. So pin number this is connected to pin number 4, and this is connected to pin number 5. Right. So pin number 4 is the output. Yeah. So pin number 4 is output, and we make use of the logic. All right. So how do we connect this sensor to the motors? I mean, this input to the hardware via the microcontroller. So for that reason, we need to make use of a third element, or the logic. Okay. So for that case, for that reason, I shall introduce one more variable here. Say for example, int c. All right. So I shall not define a pin mode to this c, because this is just a local variable. I mean, this is just a variable created for internal purpose. It doesn't have any input or output connected to this. Is it clear? Hello. Is it clear till this point?
Yes.
Okay. I shall leave some space here, and then I'll tell you why that particular space is needed, or what are we going to fill in that space. Okay. Now, as I said, we have the world around is digital and analog. So, and the other point that I told you is, we can make use of both analog and digital pins. So if the command, I mean, if the signal from the sensor is in the digital format, we need to read it digitally. I mean, we need to connect it to the digital pin and then read it to digitally. So that's the reason we are going to make use of digital read. Okay. All right. So we are going to read pin number 2. We can either use pin number 2, or we can use the variable in the connected to pin number 2, AR sensor. Okay. So whatever is the reading from this IR sensor is being stored in this variable C. Now we are going to add the logic. If C double equals to high. So hope we know the basics of basics and fundamentals of C programming language. So in that case, we are going to use double equals to compare something, to compare two variables. So here, what high means is, if the output of the IR sensor, if the IR sensor is detecting something, it will give a signal as 1. It says that, okay, there's an obstacle ahead of me. So you got to stop. You got to stop the wheels, or you got to start the wheels. Based on the logic that we need. So here high means that the IR sensor is sensing something. So the data is high. The data is 1. If it is 1, then we are going to open a loop, and then we are going to make it digital write. All right. So it is digital write. So if this particular sensor is high, it is stored here. If that value is high, that means that there is an obstacle, or there is no obstacle. The basis this particular thing, if it is high or low, based on that, we got to either start or stop the motors. Okay. So motors are connected to pin number 4 and 5. Okay. I missed this. Let me fill this up quickly. Pin mode 5, output. Okay, so I should tell my motors to start turning. So I'll tell 4 comma 5. Okay, so pin number 4 shall be digitally written. So whatever the terminal number 4 is connected to, it will be sending a command. So the pin number 4 shall be activated. So the current shall be made to flow through the pin number, to the terminal number 4. That will be in turn connected to the motor, so that the motor shall be made to run. So this is how we are going to make connect these hardware input and output hardwares. And I need a delay element. I need this motor to run only for 1 second. In that case, I shall be making use of delay element. So delay, this delay will be in terms of milliseconds. So for writing the delay of 1 second, I should give as 1000. So 1000 means that it is 1000 millisecond will be equal to 1 second. So if the IR sensor is high, the motor number 4 will be made to run for 1 second. Else, okay. So now we got to close the loop and we need to write another logic. Else if, okay, else if C not equal to high, okay, this not here, is a logical not, okay. If it is high, if it say, it says low, I mean, if C is not equal to high, that means it is low. Instead of this, we can make use of simple equal to low condition. Getting it? So in that case, we can make use of the same kind of loop but here we are going to use pin number 5. So the right motor shall be made high. So what? Okay. So this is left to the user, making high and low. I'm just showing a possibility here. And else if both, I mean, okay. So here we have only one IR sensor. Suppose if we are two IR sensors, say I'm gonna connect IR, okay, sensor underscore 1 to this, and sensor number 2 to pin number 3, and I got to define this. So pin number 3 is also input. That's also an input sensor. So here I need one more variable to store the value of the second in the IR sensor, right? So I shall make this D equals digital read IR underscore sensor underscore 2. One. Right. So this is done. If C is equal to high, C is equal to low. And here in this possibility, we can make it as if C equals to high, and D double equals to high. This means that if both the sensors are sensing an obstacle, or if they're not sensing an obstacle, you can make both the motors to either stop or to start. If they're on start, it will be stop. It will be made to stop. If they're stop, it will be made to made to start. So start running. So you can write okay, and in the same way, there's no need to give two delays, because it will be acting on the same condition. Okay. So if both if both the infrared sensors are high, or if both the infrared sensors are low, we are going to make the both the sensors go high. I mean, both the motors go high. It means that they'll start running. Or else in the other condition, I can make it as the other way around. I can make it as if C is equal to low and D equals to low, 4 can be made low and 5 can be made low with a delay of certain seconds. So what happens when I give a delay? If both are sensing high, I mean, both sensors are sensing high, both the motors shall be made to run for 1 second. For 1 second, I know I can make it 10 seconds by just adding a 0 here, by just multiplying it by 10. Okay. this is about this. So what if we are using a motor driver? So how does the code change itself when we are using a motor driver? We are not going to make any change in the code where even if you are using a motor driver, because motor driver we are going to make use of it as a hardware element only. We are not going to consider in the software loop. So instead of connecting this pin number 4 and 5 to the motors directly, instead of connecting them to the pins of the motors, we are going to connect them to the pin of the driver. So the output pin of the driver shall be connected to the motors in turn. So they shall be made to run or to stop, or to go in the forward direction or on the reverse direction. So this is about the first program that has been scheduled for this day. So we are left with 4 minutes before winding up. I'm open to questions. You can shoot them.
So the delay, I didn't quite understand why we have to put a delay.
Okay. I'll tell you what is the need for delay. Okay. Suppose I'll comment all this thing. Okay. I'll comment this part of the code. All right. So this particular part is absent. You say it's not being present in the code. If C is equal to high, okay, even this particular this thing you asked about delay. Okay, if C is equal to high, in digital write 4 comma high. If the sensor is sensing something, you will ask the motor to start running, right? And then till what point it should run. Say you have a bot, obstacle detection bot. It has got a sensor. It senses high, so it says you start moving. All right, when it says start moving, the motor start running, and then it keeps on on running and running and running till there is next command. Okay, or there should be a command that says if there is a obstacle, run for certain distance and then check for the obstacle. If there's an obstacle, then again run for certain distance. So that certain distance, what is that certain distance? We cannot give it in terms of distance. So that is the reason we are going to give it in terms of seconds, in terms of time, millisecond. If there's an obstacle, or if there's not an obstacle, you either stop for this amount of time, or you either run for this amount of time. If we don't give that particular timing over here, it keeps on doing the same action until the next command. If we don't have this command, and then if we don't give the delay, then gone case, your bot will be crushing into like it'll be crashing the whatever the obstacles are ahead of it, and then it'll be moving ahead. So that is the reason we are going to make use of delay. Got it, Shashank?
Yes, thank you.
Okay. Any more questions for the day? Okay, guys, you can just feel free and ask your questions, no matter if it's related to hardware or software or to any project. We'll just think and answer those. Any questions? You can even send those questions to me in the chat. Okay. Oh, does the recording? Yeah, maybe. Okay, sorry, I missed looking at the message from Shashank at 3:30. We are unable to hear you. Sorry, that might be due to the connectivity issue, but we had used only one sensor, right? Okay, Dhruti, yeah, we have used only one sensor there because the actual infrared sensor module was not available in that Tinkercad. So that is the reason we used only PIR. In case of PIR, we can use only one PIR, that is proximity infrared sensor. That is enough for detecting the motion. So this particular thing, whatever we discussed, this happens to be the code for the PIR sensor. If we are using infrared sensors, we can use the same code. Okay, the first part of code which I showed for only single sensor is PIR, because there was only one sensor and two motors. in case of motors, we can use lights or LED lights or anything for that matter. If you look at the horror movies, there when the subject enters the enters the hall or enters the house, suddenly the lights will be made to lit, right? So there they'll be using infrared sensor, I mean the passive infrared sensors, and then instead of motors they'll be using LEDs. So for the microcontroller, it doesn't matter if if you're using a motor or if you're using a LED. If you're connecting it to it, it just accept the command from that particular terminal, process it according to the logic that you are given, and then send a digital rate or analog rate or digital read or analog read command. Okay, I forgot to tell you about the analog right, analog read and analog write. Suppose if we are connecting this particular input to the analog pin, that is A5. So we just need to modify this to pin number A4 or A5 or A0 to A1. I mean A0 to A5. Any of the pins here can be made use of, made use for that. In that case, here I'll be modifying this as A5, and here we shall be making use of analog read. That's it. That's the only difference between this. Okay, and I also told you there's a space here, left here intentionally. Okay, that is for serial monitoring. Suppose you connected the hardware, and then the hardware is behaving, abruptly. So it's not going as per your logic. You do not know if you are, there's a case with infrared sensors. Few infrared sensors give an output of 0 when there's an obstacle. Few infrared sensors give an output of 1 when there's an obstacle. So you don't know if it is giving a 0 or if it is a 1. So based on that 0 and 1, high or low only, your complete program is based upon. So in that case, you need to monitor, what is the input that your microcontroller is getting from the input device. So for that case, we are going to make use of serial dot begin. Okay, serial dot begin. Okay, 9600. Okay, this need not be 9600. This can be anything based upon the baud rate. We have something called as baud rate when it comes to reading the inputs. Baud rate is nothing but number of bits per second. If we are reading 9600 bits per second from the microcontroller to the computer, the whatever is happening in the microcontroller, that is being read in the computer at a rate of 9600 bits per second. Okay, you can set it to 115200 or 5750 or something like that. Okay, uh, you have connected one particular cable, that is the printer cable from your computer to the Arduino for a transfer of program, right? You can make use of the same cable to look at what's happening within the microcontroller. So I'll give a serial dot begin 9600. So this will enable the serial monitoring section. And here after this, I'll be giving serial dot print. Okay, serial dot print. Okay, what is serial dot print? All this monitoring is happening on a serial communication mode. This is on a serial port, serial communication portal. So that's why we are initiating the serial serial communication at a baud rate of 9600 bits per second, and we are going to print it. So we are going to print whatever is the command. If we say hello world, it's going to print hello world. Where where does it print? It will be printing the serial monitor icon. When you download the actual Arduino IDE, there you'll be having a serial monitoring at this particular place, to the top right corner. If you click on that, you can see this. You can see serial you can see this whatever is being texted over here. If you want to see the value of this particular variable C or variable D, you just need to type the name of the variable. That's all. It will be printed on the monitor. So you can see what's the value of C. So the value of C is nothing but the analog read value of the IR sensor. So the analog read value of IR sensor is nothing but whatever analog output the infrared sensor is giving to the microcontroller. How do you run the code in this editor? It says error compiling. Okay, Sojanya. Okay, Sojanya, can you tell me, where did you try to compile? Here?
Yeah, there only.
Okay, if you check if you have selected a board and if it's currently available. All right. Okay, I'll tell you why this issue pops up. Uh, as I said, Arduino, has a very big family of members. It has got different boards, and then boards vary in terms of number of pins, terminals and pin outs. Okay, so you have A5 here. You have only A2, A0 to A5 in this Arduino Uno. Okay, suppose if you consider Uno, if you go to Arduino Mega, you got more than A10 and 8, A11 and 12. So the IDE doesn't know to which particular board you are going to apply this particular program to. So you need to select the board, right? So that particular board is not selected here in this session, in this particular window. So I just wanted to tell you by the end of this session to download the Arduino IDE. Okay, in the tomorrow's session, we'll just see how to run, how to compile and run, then how to see the serial monitoring also. Okay, today we'll just only look at the keywords and then structure of the code, and then what are the digital and out analog, digital and analog, what is the input and output. So today's session is completely dedicated to the fundamentals, right? So tomorrow we'll just see how to connect everything in order and to run them. Okay, Saujanya, that's a thumbs up from my side too. Okay, any more questions? Apeksha, will we get this recording? Yes, this recording shall be made available to you on behalf of Pylon.online by IEEE Bangalore section on their Gurukul portal. You can either reach out to Dhruti or Dr. Pushpamala. So both are very cooperative. They'll just help you reach the platform. And if you got any question, you can just shoot it, and I mean you can throw it to me.
Abhishek, I think all
So
the questions are
I
answered.
Okay, yeah, thanks, Dhruti. So I had something in mind. So um, I wanted something to deliver. So I guess I'm satisfied with this, whatever is being done for today. And I hope you got what you expected from this session. If not, just mention that what you missed out or what I missed out here in this session, so that it will be covered in the tomorrow's session. Okay, we'll just wait for 2 minutes and for your response. I know it's hard to sit for 2 long hours, but yes, we did it. Okay, guys, and let's not forget to inquire about Pyland.online. Uh, so Pyland.online is a new is a newly designed educational e-learning platform wherein our motto is to deliver as much as possible in terms of education, the quality education to the quality learners. I mean, to the best learners, from the best content creators, at a very minimal or negligible cost, that is affordable by every that can be made use by every one of us. And yeah, uh, and then our another motto is every learner can be a teacher. So if you have learned something today from this session, we are we welcome you to to get the teacher out of you, and to make you a teacher at our platform. Okay, so we have got we have trained around 30 to 40 people who are in process to get transformed from a student to a teacher. Of course, they are they're in the first year and the second and third years of engineering and other sectors of studies, like commerce and even a few law students are with us, who have transformed themselves from just from a student to a student come teacher, and and they're doing good in their profiles as teachers. So we would look forward to get back you as teachers on the platform. Okay. Okay, then. So thanks for your continuous cooperation. So let's meet tomorrow. And before that, one suggestion is you just need to download the Arduino software, Arduino IDE, and then it will allow it will ask you for allowing the access to local computers and local servers. You just need to click on allow access, or you need to grant access to the software. Just click on whatever it asks. It just click on allow, and then it will install the software for you, and we'll meet tomorrow at the same time, same place on WebEx.
Everyone who participated today, I request them to attend the session. We're done, Abhishek.
Yeah, thank you, Dhruti. And thank you, Pushpamala ma'am, and thank you, Bangalore section IEEE.